So, yes, this is going to be a little bit different, as you can probably already tell, Adam, and everyone on the call. I'm assuming most folk would normally walk through a presentation. However, if anyone's ever been on one of my bigger presentations, I'm more of a fan of the infographic. I like panning around, zooming, enhancing, going into detail, zooming out. And so what I've prepared today is an infographic where I'll walk through this in the next, I think, half an hour that I've got, Adam. So yeah, and you can see that, no issues, which is great. I will zoom in, don't worry. So yes, tonight we're going to explore Lakehouse architecture. So let me zoom all the way in. Here we go. So this presentation that I'm going to walk you through has been lifted from another Lakehouse presentation that I normally deliver to data engineering, architecture, and business intelligence teams. And I might see if I can just sort of show you what that looks like. Let's see if I can have a look. One moment. So here we go. So this is just a little example of the more technical version of what I'm about to share with you tonight. So, I would put the call out there and say, if anybody is interested in the topic tonight and does want to do a very deep dive, I do have a much bigger presentation that I can walk you through, that I'm just showing you that 30,000 foot view of on my screen right now. Let's go back to this presentation. So yeah, as you can tell, it's a little bit different. I want to begin by saying that the topic of Lakehouse is actually a really good segue into some of the other presentations that we have tonight. Helena covering accelerating value creation. Pankaj, as Adam said, I think he's unable to make it tonight. So we won't learn about data as a product tonight. But if I have a bit of time remaining in my presentation, I can maybe give that a quick 30,000 foot view. I do have an infographic on that. And Sam Elliott, really talking about data democratization as an enabler for data culture. And what I do find quite interesting about a lot of these things is that they are really around adoption, data culture. And that is quite related, as I mentioned. There's a good segue from Lakehouse, because Lakehouse is really a platform to support a lot of these other topics. So let's go down a little bit lower here. The sizzle. So I like to start with a provocative statement. And as we can see that the data warehouse architecture, as we know it today, will wither and die in the coming years and be replaced by a new architectural pattern called the Lakehouse. So this was taken from a famous white paper in 2021. I've actually got it up here in the chat window. I'm going to copy this. I'm going to put this in the chat window for everyone to take a look. There we go. So that's a link to the white paper. If anybody's interested, just have a look at the chat window down the bottom right. And it is only 7 pages, that white paper. So it is quite digestible. You can finish it in about 30 minutes to 45 minutes. And I highly suggest that everyone read that. Now, I'm going to assume on this call as well that everyone has a data warehouse in your business somewhere, in some form or fashion at least. And so as I continue through this presentation, I want you to keep your data warehouse in mind, because as this quote says, you may need to replace it very soon. And I'll make a call out to when I think that's more important. Okay. So in this presentation, I really want to equip you with the knowledge to answer these 3 questions. So what are the 3 types of data platform? What are the 3 generations of them? Why are customers demanding this newest generation called a Lakehouse? And how are the analytics vendors shifting to accommodate this demand from us, the customer? But before I sort of dive into that, a bit of an introduction to myself. So who am I? My name, as was mentioned, is Simon Nuss. I am an Aussie, and I am based out of Toronto. So very much, thanks, I saw a little sparkly there. So yes, thanks, Adam. And I lead one of the largest analytics teams here in Canada. And my team, we focus on data engineering, data architecture, governance, and report development. And we work with some of the largest organizations on the planet, basically, providing them consulting services. Go down a little bit further. Me, myself, my passion is, like all the other presenters, democratizing data and analytics. I'm a massive believer in something called data mesh, which I will touch on in this call, which is really, I guess, the answer to the question, how can I crowdsource data and analytics? If people ask me what my trade is, my normal response is I'm a data engineer, or more traditionally, I'm what's called a dimensional data modeler, which is basically that person that sits between a business user and a database. And, when I think about data, it's also how I understand business processes as well. So if I need to understand a new industry or new customer or a new client, I really do think in the world of tables and relationships. It really helps me understand the operating model. And in fact, on the topic of dimensional modeling, there's a very famous book in my trade called The Data Warehouse Toolkit. It's still the #1 book on the top of my desk. And lastly, I also love community. That's my last and biggest passion, I would say. I'm the moderator of the Power BI subreddit, having grown that to 90,000 members, one of the largest analytics communities on the planet, actually. Recently, I was made the moderator of Microsoft Fabric, and I'm a bit of a lurker on data engineering and business intelligence as well. So love the community there online. And you'll also find me at quite a few in-person meetups as well in the Toronto downtown area. Just briefly, my career, as you can see, moved from data engineering up until enterprise architecture to where I am now as the Vice President of Data and Analytics. As I mentioned, running one of the largest teams in Canada for data engineering and architecture. And, because I am a technologist at heart, I would like to also highlight my tool belt, or my stack, as we would call it. So I am more aligned to the Microsoft stack as opposed to the generic open source stack. Big fan of Azure, big fan of data lakes, Delta Lake. Been using Databricks since 2017. Power BI, well, the tools that make up Power BI at least since about 2011. And more recently, a massive fan of this new kid on the block called Fabric. And if we have some time, maybe I can dive into that. Okay. So let me just keep going. Let's dive into the topic. So Lakehouse adoption. So for the remainder of this presentation, at least, I want to focus on 3 big vendors. These are the 3 leading vendors in the analytics space. We have Databricks, Microsoft, and Snowflake. And in this section here, I really want to demonstrate that Lakehouse is real. It's not puffery. It's happening right now. Beginning with Databricks, we see, well, they actually invented the term Lakehouse. And even that white paper that I linked in the chat window was written by a lot of folk from Databricks. Here we see Arslan saying that Lakehouse is the new paradigm for data and AI. Absolutely agree. Even though they invented it and they are a little bit biased, there is a lot of truth to that. Second up, we have Amir Netz. Amir Netz is arguably the #1 expert for business intelligence on planet Earth. Famous for many, many things, many technologies in the space that we work in. And he's citing that OneLake is the beating heart of Fabric. And OneLake is just Microsoft's term for Lakehouse. And lastly, we have Snowflake. In this little snippet here, we have Dennis basically saying that there are Lakehouse capabilities that are currently in private preview in Lakehouse. So yeah, it is coming. It is a thing. Still quite new, but Lakehouse is being adopted by 2 of these 3 leading vendors wholeheartedly. Those are Databricks and Microsoft. And as we can see, Snowflake is not far behind. So at the very beginning of this presentation, at the very end of this presentation, I'll sort of recap where those vendors are in terms of their adoption or maturity with Lakehouse. And here's just a little infographic, a little picture, I should say, a little graphic on the popularity of the term sort of Lakehouse. And as we can see, since 2021, that's been trending up quite quickly, which funnily enough coincides with the release date of that white paper that I shared in the chat window. So moving along a little bit, I'm just going to walk through sort of the last 30 years of the movers and shakers, the big milestones that happened in the analytics space. Okay. Let me zoom in quite a bit here. So as you will recall, when I started this presentation, one of the key things that I'd like to give you everybody as a takeaway is to understand what are the 3 generations of data platform. And as you'll learn in the next infographic, that's not on my screen right now, each generation of the 3 is bound to a certain time period. For example, the first one's from 1980 to about 2010. And so I want to walk through these milestones that you see on the screen here to really give you an understanding or an appreciation of what's happened over the last 30 years and how it's evolved to the point we are now. I also want to highlight that a lot of the things that I'm calling out here are sort of relevant to some degree or played some big part in what we have today. And so, I'm not going to mention things like IBM or Oracle, but I will mention things like Tableau, which was, came out in 2003, but, is still absolutely big in today's market. Okay. So first we have SQL Server. I mean, this is probably the oldest and most popular database that's still regularly used today. Little footnote there. There's obviously older databases, but SQL Server is still in massive demand across the world. Next, we have the Kimball methodology, as it's called. And that is really what is a data warehouse, how to make your data warehouses. As I mentioned, the book on my desk right here. Very, very famous book. It's on the desk of every data architect. And as the practice of data engineering is emerging, it's now getting a lot of traction and a lot of adoption in the data engineering space as well. So that I guess dipped a little bit over the last 10 years as we had a lot of software engineers entering the data space, but they've very quickly begun to realize that you need a framework, and Kimball is coming to the forefront of that yet again. We have MDX, or multi-dimensional cubes. These are the backbone for pretty much every BI tool on the planet for the last 20 years. As I mentioned, Tableau recently sold to Salesforce, waning a little bit these days, but has been dominating, I would say, for like the last 10 years in the BI space. I've brought in the Hadoop picture here, but saying that this is the release of Google MapReduce, which is really the start of big data. It was really sort of the guiding light post that started the big data movement and gave direction or a framework on how to do big data. And that was really, Hadoop is very big even to this day, but I would say it was really overridden or overtaken by Apache Spark that came out in 2010. And so Spark is obviously huge in the industry. And even to this day, I'm going to guess it's probably the #1 analytics product on the market. Like Spark is the back end of Databricks. Spark is the back end of Synapse. Spark is one of the key components in Fabric, right? Spark is everywhere. That core engine is everywhere across the industry. Next, we have Snowflake, absolutely dominating the industry in terms of just pure databases in the last 4 to 5 years. Doing an incredible job there. And then we have not really technology, but I always like to call it out. Data science, the sexiest job of the 21st century. I'm not a data scientist by trade. I'm a data engineer / data modeler, as I mentioned. But, I think it's very much worth calling out because a lot of these tools have shifted to accommodate data science. Spark especially. Spark is one of the predominant data science platforms out there, especially on big data. And Databricks, another huge milestone, right? The creators of Spark. Yep. And just to Adam's point, guys, in the chat window that he just made, if you do have any questions, please put them in chat. I'll try to keep an eye out on it and answer them live, or at the very least, I'll answer them at the end. And we have Databricks here, of course, another huge milestone, as I said. As I said, it is backed by the Apache Spark engine. In fact, the person who invented Spark and open sourced it made Databricks. He basically took Spark, packaged it up, added on some fantastic IP, and then made a product that's a managed platform and called it Databricks. So they're pretty much the same thing, but Databricks has taken Spark and ran with it. And then my personal favorite, I am slightly biased towards it, being the moderator of the Power BI subreddit, is Power BI in 2015. And with only a few years after its release, 4 or 5 years, it's now dominating the whole BI market, which is fantastic to see. And we have just a couple of, I guess, principles or frameworks, depending what you want to call them, to wrap this up. We have data mesh, which, as I mentioned before, basically answers the question, how can I crowdsource data and analytics within my organization? How can I get my business users using analytics instead of a centralized IT team? So it provides that guidance, those guardrails, really around 4 principles. So data mesh is an evolving, I guess, concept right now. It has been successfully implemented in some companies, but I am personally a massive fan of it. And last but not least, we have the the Lakehouse white paper, which, as I said, 7 pages, half an hour, 45-minute read. It is the impetus for this call, this presentation. So please take a moment to have a read of that in your own time. Once again, link is in the chat window. And of course, we do have a couple of honorable mentions here down the bottom. Excel, just want to call it out. It is the world's #1 BI tool. I said it. We all know it's true. Deal with it. So Excel, I'm not going to put it on the chart, but it is the most popular analytics tool on planet Earth. And a few others there as well you can have a look at. I will share this infographic after this call, guys. So, if there's anything you've missed, I can share this afterwards and you can have a look at it. So let's get into the meat and potatoes. So what are the 3 types of analytics platforms out there on the market? I've really consolidated into three buckets based on that white paper. The first one is the generation 1 monolith, as I call it. And let me just zoom in here to sort of conceptually show you how it works. So at a very high level, in a data warehouse or a data platform, you've got 3 hops with this generation 1 design. You've got a data source, which is an application. Then you move that data out of it, you copy it, you duplicate it into another system called a database. And then you do some transformations, or you do them on the fly. And then you load the data again to a report, a pie chart for argument's sake. So that's a generation 1 monolith. And I've just listed for each sort of generation some of the challenges that it imposes. And the biggest problem with the first one, I think, is that it just did not support unstructured data. Databases can't host images, pictures, audio, compressed files, things like that. They don't handle it very well. Okay. And so they also don't support AI/ML natively. And so what that means is that if you wanted to run some very large, exhaustive data science models, the first step is usually to extract the whole dang database to a separate system. And that just doesn't make sense. And there are a few others there as well. Streaming is not very elegant in these older systems. Managers are forced to hire talent based on the technology. And we're still in that mindset today, by the way. The database vendor, they own everything. They've got you over a barrel, unfortunately. They control all the costs, all the licensing. You are beholden to that database vendor. And lastly, migrations are expensive. I'm going to guess every 5 to 8 years, there's a data warehouse migration on average. And so every 5 to 8 years, you need to fork out $500 to $5 million to move to the latest and greatest database. So these were some of the challenges with that design. And this design really ended in 2010. And in 2010, we had something new that came along, a data lake. And so what is generation 2? What is this 2-tier design? Well, this is kind of where we're at today. And I reckon that most folk on this call are probably using something like this design. So yeah, as we see, data source, just like before, we have a database just like before, and a report just like before. So we've added something. We've actually increased the amount of data hops in our supply chain with a data lake. So we've actually made it more complex. But in doing so, we've solved some of those challenges. Now we can store images in the data lake. We can analyze images and video and unstructured data. AI/ML is supported. You can run your code very close to the data without doing these massive extracts, usually with Spark. Streaming real-time data is relatively easy to do in this design because you can stream to files in a data lake. And for those of you who are not aware what a data lake is, it's just files and folders. And if anyone tells you anything else, they're lying. Data lake is just files and folders, literally nothing more than that. So it's very easy to stream data into files and folders. So streaming was solved as well. However, it didn't solve a few things. As I mentioned, this is where we're at today for the most part. Managers are still hiring talent based on technology. Look at any job requisition or any job posting. I bet you're going to see, Amazon, Azure, or Netezza or Synapse, right? We're hiring around technology. Moreover, you're still beholden to that database vendor. The database still exists. Migrations are still expensive. But it introduces a few extra challenges as well, these 3 ones down the bottom. Security and business semantics are widely spread out. So what I mean by that is that you have security at your data source, security at your lake, your database, and your report. Moreover, your business logic can be spread across all 4 areas. And also, we're duplicating data. We've got data in our data source, the same data in our data lake, probably the same data in our database, and probably aggregated data in our report. It just doesn't make sense. Why are we duplicating data? And so very simply, that brings us to Lakehouse because it solves a lot of these challenges. So I want you to imagine that you have a data warehouse full of tables that you want to query. How do you do it? You connect to that database, data warehouse, you write some SQL, you join some tables, and voila, there's your data. That's how it's worked, and that's how it's always worked for like the last 40, 50 years. But what if I told you there is a way to query your tables without going through the database? A way that lets you really use any technology or programming language that you want to query your data without going through a single vendor. It basically lets you select the ideal compute engine for the task at hand. And for those of you who have not been paying attention for the last couple of years, this is what Lakehouse sort of brings to you. Generation 3 Lakehouse. It really gives you, it liberates your data is another way to put it. It removes it from the hands of those greedy vendors who want to lock it down and charge you extra to pay for the next feature. And so this is really how it works. We have a data source. We still have to copy that data into a data lake, but that's it. At this point, all of your transformations are done within your data lake. In fact, even your database semantics are in your data lake. Your data lake is your database. That is effectively what Lakehouse is. So at no point will data be copied outside the data lake or the Lakehouse. That is the house for your data. That is the database, the warehouse for your data. And any report or any piece of compute is actually pulling from that data lake in real time. Okay. And so it solves a lot of those challenges. I'm not going to go through and read them all. You can see them on the screen here. But some to call out is that it removes the vendor from the equation. We no longer have a vendor database holding all of your data ransom. It is in an open format, just files and folders on a data lake. Another one is that you now no longer need to hire your analytics teams for technology. It's not a Tableau or a Power BI discussion. Now it's a Tableau and Power BI discussion, because now you can use any technology. It's not this database or that database. It's this database and that database. So all languages can be used against this paradigm, but it does still have a few more challenges. The first one is that performance is still not there yet. If you have all your data in a database, it's extremely quick, but pulling from a data lake incurs IO, disk IO costs or in-app costs. And that's a performance hit. And they're still trying to get these lakehouses up to a certain speed. More tooling means more data governance challenges, means more procurement challenges, but it also means happier end users, right? And we know this from data mesh, right? So it's a bit of a balancing act, but ultimately we know our business users are demanding to use the tools that they want to get their own job done. You cannot do that with this generation 2 design. It is technically impossible. So you have to adopt a Lakehouse design if you want your end users to use the tool they want to solve their own problems. And lastly, and this is very technical, and I saved this for the other presentation, some security constructs, RLS, OLS, dynamic data masking, unfortunately, they require a database, but topic for another day there. So that's a very high conceptual view of what the 3 generations are. Now I want to just focus on Lakehouse to give you some pragmatic or some practical examples. And so, yeah, just to recap, we have the same visual up the top here. Nothing's changed. And I've taken that visual and I've put it into an actual architecture here. Very simplified one. So on the left here, we have Databricks, right? We have a data source. Let's pretend it's your CRM system like Salesforce. Databricks is pulling that information into files in your data lake. Then it's transforming that data, saving it as more files in your data lake, really enriching it, that environment. And then in this case, Power BI comes along and reports on that in real time. Okay. And in Microsoft Fabric, the flow is the same. It's just now it's a different tool. It's a different tool doing the same flow. It's a different tool pulling the data, transforming it, and reporting on it. But why Lakehouse is interesting is you can mix and match. You can use any tool you want to do any job within that data lake. Moreover, you can use any tool you want to extract an interface with your data within that data lake. And so this is what a mature data, very simplified view of what a mature Lakehouse may look like. Many different tools. It's a very polyglot environment. Many different tools doing many different things. Usually picking the best tool for the job effectively. Now let's imagine you've got everything in Snowflake or you've got everything in SQL Server. You can't pick the best tool for the job because at the end of the day, you're running Snowflake code. It's in SQL Server. You can't pick the best tool for the job because at the end of the day, it's running SQL Server code. But with Lakehouse, no, you can run any piece of code or language or engine or calculator that you want. And that's sort of what it looks like there in practical terms. Adam, I'm not sure sort of how I'm doing for a time check here. I mean, how much longer do I have? Is it about 5 or 10 minutes, or am I getting near?
Yeah, no, that's fine because we had one of the other chaps drop out, mate. Yeah, go for it.
Excellent, cool. So what I'll do is I'll just take this here and maybe peel the onion back a little bit further. And once, as I said before, I am going to share this infographic after the call. So, I won't go through this entire diagram here. So what I've done here in this diagram is taken once again the first gen, second generation in Lakehouse and provided a bit more depth to what each one means. I don't think I'm going to go through these, by the way, on this call because I've already spoken to it at a deep enough level. If you'd like me to go through these in detail on another call, once again, reach out to me on LinkedIn. More than happy to do that. But one of the folk who actually I pulled out of tonight was going to talk about something called data as a product. And so what I would like to do is maybe just recognizing that there's some folk on this call who maybe wanted to hear about that. I do want to, maybe I can talk about that at a very, very high level. Okay. So data as a product is one of the 4 key principles of something called data mesh that I've mentioned a few times. And it's really illustrated here in this pillar here on the left. And the way to think about data mesh, it's more the how to analytics. How do you implement it? How do you democratize it? Whereas Lakehouse is more the what. What is the technology you're using or the framework that you're using, okay? So data mesh is more the how. And as I mentioned, one of the principles in data mesh is data as a product. The other ones are, I wasn't actually planning on presenting on this. I'm testing myself now. Decentralized data governance, self-service analytics, domain ownership, most important one. So those are the 4 principles of data mesh. But one of them is data as a product, which means bringing that agile product design thinking to your data or your products that you make around the data. And so I'll just walk you through sort of what that means from a data mesh perspective. As I said, very, very high level. And so when we look at data as a product, there's sort of 2 layers to data as a product. And by the way, to give that some practical terms, a data product could be anything. It could be a data warehouse. It could be a pie chart. It could be an Excel report, a Power BI report. It could be a data model. It could be a Spark notebook. Like a data product is anything that really consumes data and produces something of value. It's a very loose term. And so in this flow here, it starts down the bottom with our data sources. In this case, structured, semi, or unstructured data. And the first layer, as I said, of the 2 of data product are something called source-aligned data products. So let's imagine that you've got a Salesforce instance, and marketing probably, or your sales team probably owns that Salesforce instance. What data mesh says is that, hey, sales, not only do you use Salesforce, but you are responsible for democratizing that Salesforce data to the rest of the organization. And so what they need to do is to, 1, pay the Salesforce costs. Then they need to build what's called a source-aligned data product. And that's really a product that democratizes their Salesforce tool to the rest of the organization. So that's the first layer, source-aligned data products. They are a one-to-one match of your applications. In this example, Salesforce. And then, say, for example, you work in HR and you need access to that Salesforce data. What you can do is you can create that second layer. And that's called a consumer-aligned data product. So I'm HR, and I'm interested in getting access to Salesforce data. So I connect to the source-aligned data product. I make a beautiful pie chart, and that pie chart is a consumer-aligned data product. And that's the second layer. And that's pretty much data mesh, data as a product in a nutshell. Data mesh is quite deep. It's definitely a conversation that I can't do justice on this call, but that's your 30,000, 3 or 4 minute pitch on data as a product and data mesh. And I apologize, that was quite impromptu. I didn't plan to speak about that. So as I said, I will share this infographic. You can have a look at these blue diagrams in detail later. And so let's just wrap this presentation up in a few quick summaries. So you have a lakehouse in your organization. Remember I asked you to think about your data warehouse? If your data warehouse meets these 4 tick boxes, it's actually a lakehouse. So your data ends at the data lake. At no point are you copying that data into Snowflake. At no point are you copying that data again into SQL Server. It's redundant. It doesn't make any sense. So your data ends with your data lake. You're not tied to a single vendor. So if you're with SQL Server, you should be able to query those SQL Server tables without going through SQL Server, right? Same with Snowflake, same with anything else, right? So that's one of the litmus tests. Your analytics stack, whatever it is, because it can be anything, pulls data on demand. It's ephemeral. So when you click run on whatever that script or visual is, at that second, it's going to the data lake, pulling the latest data, okay? Everything around your lakehouse has to be ephemeral, has to be on demand, has to be serverless. And lastly, your data is stored in an open format. It is not proprietary. Snowflake, get with it. So it has to be stored in Delta Lake, Iceberg, or Hudi. In Snowflake's defense, they actually have Iceberg in private preview right now. So they're working on it. Customers are demanding Lakehouse because data is removed from the migration equation. When I need to update to a new data warehouse every 5 to 8 years, I'm not moving data anymore. I'm just moving the code. That's what Lakehouse gives you. Remember, the data is open. It's not proprietary. You don't need to move it. You gain leverage over your vendors. If your vendor is going slow, there's performance issues, don't worry. Just pick another vendor. Your data doesn't change. Just the technology used to query it. Very simple. You can hire your team on the business need, not the technology. That is critical. I hope to one day see job descriptions that don't list technology. right? We want you to be an HR analyst. Use whatever tool you want. That is Lakehouse. There's fewer hops in the data supply chain. There's in-platform native support for data science or streaming, right? I don't need to rely on other tools. My performance isn't going to take a hit. My costs are not going to go through the roof, right? That's what Lakehouse gives you. It enables data mesh, I think, as I've spoken about. And basically, customers are tired of putting all their eggs in one basket and then realizing there's a problem. We've seen it for 40 or 50 years. As I said, every 8 years, we move to a new database. We start populating it with data. It goes slow, or it's no longer the new thing, right? And then all the vendor, heaven forbid, is charging you $1,000 for every click of a new feature, right? That goes away with Lakehouse. And so I'm going to wrap up this conversation with just a high-level summary of the 3 leading vendors and sort of where they're at in this journey of adopting Lakehouse. Beginning with Databricks, as I said, they invented Lakehouse. They are Lakehouse at its very core. They've elected to use something called the Delta Lake format, which is that open format. It was one of the 4 criteria to be Lakehouse. I didn't go into detail on this in the call because there's not enough time. There's something called Unity Catalog, which is sort of tying together a lot of that data and helping democratize it. And they're sort of using, I won't go into that last bit. I'm a little concerned about the last one. Snowflake, as I mentioned, they have a private preview of Lakehouse, basically. So they actually have a private preview of Iceberg, which is a file format of Lakehouse. Currently, they store all of their data in a proprietary format. But if they do decide to adopt Iceberg to read and write to it, that will be a true Lakehouse. It'll allow you to circumvent Snowflake to query Snowflake data. Let's see how they do that. And then Fabric, which is the new kid on the block. This was only announced 2 or 3 months ago, but it took the whole industry by storm because it is an end-to-end analytics platform, the very first one in the world, all within one platform. And it is Lakehouse. Like Databricks, they've adopted the open format of Delta Lake. But unfortunately, it's in public preview right now. TBD. I think it's one of those, watch this space, come back in a year, and I think that's going to be, if not dominating the industry, very quickly getting there. And I say that because it's run by the Power BI team. And if you've ever seen what Power BI did to the industry, they're doing the same thing for everything else in the analytics stack. And so I'll leave it there, guys. Thank you very much for the time here.